Hey guys, I'm Grant Helms, and this is my 2211 Constant Velocity Lab. First, a little introduction to the lab. Basically, you were to give an object some sort of constant velocity and track it using a tracker software, taking a video of that velocity, and track it, and then try to replicate that motion in GlowScript using physics principles. Um, look into the physics principles first. I only really had to use the velocity update formula for this lab. So basically, I use data from the tracker software, which would be the initial velocity, the change in time, and the force net calculated using acceleration times mass to calculate a final velocity for each changing time interval. And that's how I created my GlowScript code. First, the observed motion. A few assumptions. Well, one assumption: the motion is only in the negative x direction, and that will come into play later. You'll see, because I think there was a little motion in the z direction, but I did not calculate for that. The systems of the ball, the surroundings are the floor, which causes friction, and the foot, which is an applied force. In the initial conditions, an applied force is given a basketball some initial velocity in the negative x direction, and here is a video of that.
Yeah, we straight. Go ahead. Yeah, we straight. Go ahead.
All right, so here's the tracker graph I got from that. As you can tell, motion starts around 2 seconds into the video. When I write my GlowScript code, I started motion at 0 seconds just to make it easier to compare. But the position versus time graph is relatively linear. There is some slight acceleration, which is interesting, but I think that's a factor of the z direction kind of coming into play in the video. My GlowScript code, I had four variables: mass, position, velocity, and force net. All of those were, except mass, were derived directly from the tracker data. So the position, the initial position, that is, the initial velocity, and the force net were calculated from that. Um, and then to actually create motion, I used the velocity update formula, um, which you can see there using the variables I created earlier. And then I updated position using position update, just multiplying velocity by change in t. So the GlowScript graph, the position versus time is extremely similar to my observed data. Velocity versus time again has some sort of positive acceleration in the negative direction, which is interesting. But once again, I think that's a factor of the z direction. Data comparison, once again, the predicted data in blue is very similar to the observed data. Um, Of course, I start at 0 seconds for this graph, but yeah, slight acceleration due to that z direction. The what if, what does it mean? First, the what if you flip the axis, my motion in the video was from the right to left, so that would be negative motion, giving you a negative slope in the position versus time graph. Um, but if you were to flip the axis, that would just make the motion or the slope of the position time graph positive in the position versus time graph. So you can see that the first graph there on the left would be an example of what my motion actually looked like, but the right is if you would flip the axis, and that is for position versus time. And the what does it mean? Basically, I did not assume zero net force in my video just because there was such a strong force given by the tracker. But in theory, yes, you to get constant motion, you would have to have some applied force, which would be equal to, well, equal but opposite to the friction force of the ball rolling on the floor, and that would give you a net zero force, giving you constant velocity. But just in my case, I couldn't do that given that there was such a strong acceleration, I guess, due to just the way my video was filmed. But yeah, thanks for watching.